Hello everyone and welcome to CSC211 Data Structures and Algorithms course. In this lecture we will be exploring the various types of data structures that are commonly used in computer science. Data structures are essentially ways of organizing and storing data in a computer program. There are different types of data structures, but they can be broadly categorized into two main categories: linear and non-linear. Linear data structures are those where data elements are organized in a sequential order. Examples of linear data structures include arrays, linked lists, stacks, and queues. Whereas non-linear data structures, on the other hand, do not follow a sequential order. Example of non-linear data structures include trees and graphs. Arrays and linked lists are two main implementation approaches for data structures. Arrays are easy to use and efficient, but they can have a fixed size and can waste memory if underutilized. On the other hand, linked lists are more flexible and dynamic, but accessing an element in the list can be time consuming. Linear data structures are the simplest and most common type of data organization. In this type, data elements are arranged in a sequential manner, making it easy to implement in computer's memory. They have a strictly defined one successor and predecessor except for the starting and ending data elements. Some examples of linear data structures are arrays, stacks, queues, and linked lists. Arrays are a collection of data elements stored in contiguous memory locations, while stacks and queues are similar structures that use the principle of first in, first out, and last in, first out, respectively. Linked lists, on the other hand, are structures that use pointers to link data elements. In nonlinear data structures, data elements can be attached to several other data elements to represent specific relationships that exist among them. This makes it easy to represent complex relationships between data elements that cannot be represented in a linear structure. Some examples of nonlinear data structures include trees, graphs, and heaps. Trees are structures that have a hierarchical arrangement of data elements with a single root node at the top and branching out to multiple child nodes. Graphs are structures that have a collection of vertices and edges connecting them, with each vertex representing a data element and each edge representing the relationship between them. Heaps are a type of tree structures that is used to efficiently manage data elements in a priority queue. In summary, data can be organized in two main types of data structures: linear and nonlinear. Linear structures are organized sequentially, making them easy to implement in memory and having a strict one successor and predecessor. Whereas nonlinear structures can represent complex relationships between data elements, making them suitable for more complex data organization needs. Understanding the different types of data organization is essential in choosing the right data structure for your programming needs. Now let's take a look at the two approaches to implement data structures. The first approach is contiguous memory allocation using arrays. In this approach, the data elements are organized sequentially in memory and each element is accessed using an index. Arrays are easy to implement in computer's memory as they occupy a single block of memory which is divided into uniform sized cells to store a fixed number of data elements. Arrays are commonly used in data structures such as stack, queues, hash tables, and adjacency matrices. However, they have some limitations such as the memory wastage when the actual number of data elements is less than the actual capacity, and the inability to dynamically allocate memory when more memory is required at runtime. The second approach is linked memory allocation using linked lists. In this approach, the data elements are stored in nodes and each node contains a data element and a reference to the next node in memory. Linked lists are dynamic, meaning they can allocate memory on the fly when more memory is required at runtime. They are commonly used in data structures such as lists, trees, and adjacency lists. However, they involve the use of pointers or references, making them more complex to implement than arrays. To sum up, contiguous memory allocation using arrays and linked memory allocation using linked list are the two fundamental approaches to implement data structures. While arrays are easy to implement and have better cache locality, whereas linked lists are dynamic and do not waste memory. Ultimately, the choice of approach depends on the specific requirements of the data structures being implemented.